Hi, this is Miss Lee, and today's video lesson is on fraction, decimal, and percent equivalent benchmarks. Fraction, decimal, and percent is also referred to as FDP, meaning fraction, decimal, percent. Equivalent means equal. What do I mean by that? I can write the fraction 3/4 in decimal form, which would be 75 hundredths, and I could also write it in percent form, which would be 75%. These are equivalent values. 3/4 as a percent is 75%. As a decimal, 75 hundredths. We're going to start learning how to convert fractions to decimals and percents, or decimals into percents and fractions. And today our focus is going to be on the benchmarks. Benchmarks are those fraction, decimal, and percent values that we're going to use all of our life. They're the most common ones. They're ones that you should know, you should have memorized. If you're given the fraction 3/4, automatically you should be able to tell me it's 75 hundredths or 75%. Or if you're given the decimal form, you should be able to tell what the fraction and the percent form equivalents are. So go ahead and make sure that you have your notes out. You're filling them as you go along with this video. Pause the video when necessary so that you can stay caught up with your notes. Let's go back and do a quick review over what you've learned in elementary school concerning fraction, decimal, and percent. So we have three models here. We have a fraction model, the decimal model, the percent model. Each model represents one whole. And these three represent equivalent amounts. So how are they equivalent? Let's take a look. First of all, what shaded fraction is represented here? Well, if you look, this whole is cut into 5 equal parts, so that's your denominator. Only one part is shaded, that's your numerator. So the fraction represented in this model is 1/5. Then we learned about decimals. You learned about the tenths place. You learned about the hundredths place. And you saw these whole models when they were cut into columns like this, or they could have been rows going across, but each one represented a tenth. And if you would add them all up, it would equal one whole. Since we have two shaded columns, that means we have 2 tenths. 1/10 plus 1/10 is 2 tenths. That is the decimal value represented in this model. 1/5 and 2 tenths are equivalent. Take your decimal model. You can see it's the same size. The whole is the same size. They're not different shapes or different sizes. And the shaded amounts are also the same amount. So these are equivalent. Then if we move on to the percent, you notice that this is a hundredths grid because you learned that percent is always out of 100. So if you were to count up each hundredth square, there would be 20 of them. And any number out of 100 can be written as a percent. So this would be 20%. And again, it's the same size as your decimal model and as your fraction model. The shaded amount is the same amount as the fraction and the decimal shaded amounts. So this proves that all three forms are equivalent. 1/5 is equal to 2 tenths and also equal to 20%. So using our models, we're going to go through and talk about the benchmarks. The first benchmark is 1/2, the fraction 1/2. 1/2 means that 1 is shaded out of every 2. So I'm going to go ahead and shade this on the model. And for every group of 2, like this group right here, I'm only going to shade 1. So I'll shade 1, I'll leave the second one blank. Then my next group of 2, I'll shade 1, leave the second one blank. The next group of 2, I shade 1, leave a blank. Shade 1, leave the second blank. Shade 1, leave the second blank. Now I'm ready to start the second column. I shade the first square, leave the second blank. Shade the first square, leave the second blank. Shade square 1, leave the second blank. Shade square 1, leave the second blank. Shade the first one, leave the second one blank. And you can tell that a pattern is starting to form for what should be shaded. So if I continue and shade 1 out of every 2, my completed model is going to look like this. I have just shaded 1 out of every 2 squares. This represents 1/2 of the model being shaded orange. Now, if I consider this as a decimal, and each row is a tenth, I count up, I have 5 rows shaded. So that means the decimal shaded is 5/10. As a percent, I have 50 squares shaded. Count them all up, there's 50 squares shaded out of 100. And again, because it's out of 100, we can write it as 50%. If you wanted to think of it as money, you could think of it as half of a dollar. Half of a dollar bill. A whole is a dollar bill. Half of a dollar bill is how much money? 50 cents. And that's still going to be 50%. Okay, moving on to the fourths. Okay. We're going to start with the fraction 1/4. We're going to model it. 1/4 means 1 is shaded out of every 4. So I'm going to shade my first square, and I'm going to leave squares 2, 3, and 4 blank. Then I start over with a new group. Shade square 1, leave 2, 3, 4 blank. Start a new group. Shade square 1, leave square 2, 3, 4 blank. Start a new group. Shade square 1, leave 2, 3, 4 blank. Shade square 1, leave 2, 3, 4 blank. Shade square 1, leave 2, 3, 4 blank. Shade square 1. And I'm going to continue and shade my whole model 1 out of every 4, and this is going to be my completed model. This model is now showing 1/4 of the squares being shaded. So let's think of this as a decimal model. I don't have any rows or whole rows or columns shaded, so I'm going to have to look at the little squares, which each represents 100th. So if I count them all up, there's 25 shaded. So 25 hundredths would be the decimal equivalent value. And again, 25 out of the 100 squares shaded means that this is 25%. If I wanted to go to 2/4, that means I'm adding another 1/4. So I'm doubling the 1/4 amount. Instead of 25 hundredths, I double that, and I get 50 hundredths, or you could drop the last 0 and write it as 5/10. Double the 25% and you get 50%. Which makes sense because 2/4 actually simplifies to 1/2, doesn't it? And we just talked about 1/2 up here. 3/4 means I'm tripling the 1/4 amount. So 25 times 3 is 75, so it would be 75 hundredths. The percent would be 75%. If you wanted a quick way to remember this, so you can have it, you can memorize it easier, think of quarters. The denominator is 4. 4 quarters make 1 whole dollar. So every time you see 4 as the denominator, you should think of quarters. So somewhere next to this model, go ahead and write quarters. Think quarters. Four quarters make a whole dollar. That's the denominator. The numerator tells you how many quarters you have. And 1/4, you have 1 quarter. 1 quarter is how much money? 25 cents. 1 whole dollar is how many cents? 100 cents. So 25 cents out of 100 cents can be written as the percent, 25%. Here I have 2 quarters. 2 quarters is 50 cents, which is 50%. 3/4 means that I have 3 quarters. 3 quarters is 75 cents, which is 75%. Okay, let's talk about the eighths. 1/8. This means I'm going to shade 1 out of every 8. So I'm going to shade 1 square. Leave 2, 3, 4, 5, 6, 7, and 8 blank. Then I'll shade square 1 out of the next group. Leave 2, 3, 4, 5, 6, 7, 8 blank. Shade 1. Leave 2, 3, 4, 5, 6, 7, 8 blank. Shade 1, and so on. When I get done shading every 1 out of 8, this is my completed model. Now, I'm going to take a closer look over here. If you look at the last two columns, you'll see that I started a new group up here at the top. So I shaded 1, left 2, 3, 4, 5, 6, 7, 8 blank. I started a new group and shaded 1, left 2, 3, 4, 5, 6, 7, 8 blank. And now I'm ready to start a new group. I can't shade this first square because I'm supposed to shade 1 out of 8, and there are not 8 squares here. There are only 4. What can I do to turn these 4 squares into 8? Did you say that I could cut each one into half? Hopefully that's what you said. And if you cut each one into half, you now have 8. And now I can shade 1 out of 8. So that's why when you look at this last column, this last square shaded, only half of the square is shaded, because I had to cut each one into half. So this model now represents the fraction 1/8. For the decimal, I can count up all the 100 square, and I have 12 of them, and then I have half of 1. So I actually have 125 thousandths. If we're looking at this as a percent model, I have 12 whole percent and a half shaded. For 2/8, I'm just doubling the 1/8 amount. So I'm taking the 125 thousandths and I'm adding another 125, and it's going to give me 250 thousandths, or you could drop this last 0 and just write it as 25 hundredths. If I add another 12.5%, I get 25%. For 3/8, I do the same thing. I add another 125, and it's going to give me 375 thousandths, which is 37.5%. Add another 125, and it's going to give me 500 thousandths. You could drop the zeros and list it just as 5/10 if you wanted to. The percent, if I add another 12.5%, I get 50%. And I continue to do the same thing, and 5/8 is going to be 625 thousandths, which is 62.5%. 6/8 is going to be 750 thousandths. You could always drop that last 0 and list it as 75 hundredths. The percent would be 75%, and 7/8 would be 875 thousandths, which is 87.5%. There really is no quick and easy way to remember the eighths, other than maybe think of it as the 125.125. You could also think about the fourths. Here I have, pretend these are all equal amounts. I have my whole cut into fourths. I can cut each fourth into half, and that's going to make my eighths. So if 1/4 equals 1/4, 25 cents, then I could take my 25 cents and I could divide it by 2, and that's going to give me the 125 thousandths. So you could think of it that way. You could also see if you can simplify. 2/8, that actually simplifies to 1/4. 1/4 is 25 cents. 4/8 simplifies to 1/2. We know 1/2 is 50 cents. 6/8, divide both numerator and denominator by 2, and it equals 3/4. 4 is 1/4. 3/4 is 75 cents. That's another way to think of your halves. Okay, go ahead and move on to FDP Benchmarks Part 2 video.